Good morning, everyone. Sorry for being late, but there was a technical problem that prevent accessing the online session. Um, I tried Chrome, Google Chrome, and it's accepted. Now, let me just share the chapter slide. This one. So we are in chapter number 12. Okay.
B behind.
I think you got it.
Yeah.
Yeah?
Yeah.
Okay.
And
yeah?
R1.
Yeah. Okay, perfect. Okay. One more and then we will start, okay? Good morning, Jinan. Good morning. Okay. We will have like a game here. We are having a game, like this one. Let me just share. Let me think about something hard. Think about easy. Okay.
How many letters?
Three, nine characters. Hey, which one? Because you are wearing mask. I'm not sure what. Okay, so A. Unfortunately,
E.
E. Y.
شوي.
أنا بسرعة بخلص. يلا. What else? I didn't share the camera. Sorry. Yes. F.
You should ignore the heavy base, okay?
All right.
U.
U. C. Oops.
Okay.
Just a minute. O. Yeah.
Okay.
M. L. N. Sorry, I will remove this. Computer. This is correct. Sorry.
What?
My bad. Yeah. E is correct. T. Sorry. أبي بس هاي. Okay. No. What else? Any letter? You want me?
You want one? Composite.
Correct. Example. Composite. Okay. Correct. Okay, so that was all for after breaking half the lecture time, mashallah. Okay, anyway. Okay, so we have discussed the type of attribute. Okay, how many elements? How many elements for the ER model? Main concepts. We discussed them before. There are 4. Can anyone tell? Anyone? Anyone from online students also? 4. We have 4 main concepts. When we want to draw an ER diagram, for example. Yeah. Let me draw it for you. Okay, so this is number 1. For example, entity types. Relationships. So entity type. Yes, this is relationship. And what is coming inside? Attributes. Correct. And what else? For example, student. This is the universal example. Student course. Okay, what comes inside? ID and so on. Code and so on. Okay. What else? Constraints, exactly. So number 4, constraints. These are constraints. The constraints are structural constraints, which are related to the relationship. And for example, you can see here, for example, student. One student take many courses. Okay, courses. Many courses are taken by, for example, many students. Okay, for example, this is just in the, or each course is taken by many students. So one to many. This is something we call structural constraint. It's restricting the number of what students, for example, courses or students or objects. Let's say objects that are participating in the relationship. All right. So this is what we mean by constraints. All right. So let's go back to the chapter and discuss the constraints. Just start this one. All right. Is it called Void Darla? Are you with me there, students? All right. Perfect. Okay, so let's discuss the remaining part for this chapter slide. Maybe if we have time, yani, within this lecture, we will finish it. Otherwise, we will finish it by Tuesday. Because it's 50 minutes and beginning of each lecture will be wasted with connecting and these things. All right. Now, yeah, by Tuesday, inshallah, I will bring some activities for you, okay? Like previous chapter and this chapter slide. So there are some activities that you need to just more practice and refresh your memory about what's the meaning of relational model, what's the meaning of ER model, all right? Okay, so let's talk about the constraints. Today we are going to talk about the constraints. We stopped here previously, right? We stopped here. We said another type of attribute that is calculated based upon another attribute or another piece of data. Okay, like for example, age and date of birth. Age and date of birth. All right. So age is it's not necessarily existed, but it's calculated based on date of birth. All right. Now let's talk about the candidate key. We have discussed candidate key before, right? We said it's. I have mentioned this before, right? I said it's the identifier, or sorry, the attributes that uniquely identifies each entity type. Okay, and it has distinct value, cannot contain null. So this is like, for example, the branch number. For the branch relation, it has a distinct value. It has a distinct value and cannot contain null. This is the candidate key, or we can say CK by short. We can say CK. Okay. An entity type must or might contain more than one candidate key. Like, for example, we said candidate key or candidate key can be different keys. Can be primary key, or what else? Primary key is selected to uniquely identify this object. Okay, primary key is the attribute that is selected to uniquely identify a specific or particular attribute. Okay, this is the primary key. How about other types? Can anyone tell? Other types of keys? Foreign key, yes, exactly. This is something in another relation that can be related to the primary key in a base relation. Okay, so it will ensure linking between two different entity types. All right, what else? Alternate keys. What are alternate keys? Alternate keys are candidate keys that are selected, sorry, that are not selected to be primary keys. Okay, so alternate keys, something else, not primary key, not foreign key. So these are alternate keys. All right. So we said first we have primary key that are selected to be. Sorry, I have bad. Bad handwriting in using this, yani, the ink here. Okay, let me just write it here. So primary key, we have, so PK, we have foreign key. Okay, we have alternate key. All right. So the alternate key that are not selected to be primary key. Okay, not selected to be primary key is alternate key. How about something if we have, for example, one entity required more than one primary key? It happens, right? For example, when you let's talk about this example, property for rent. Someone views a property, okay, and there is another guy from the same company who guides this customer or client. Okay, he is guiding him. So the viewing entity, it might include two primary keys. There are two main keys or two main attributes that identifies each object from this entity type. For example, the property and the client, let's say. And there might be, for example, the other person, or it cannot be the other person, the staff member. I mean, the viewing can include two primary keys, which are client and property ID. Got the point? Viewing, when I am viewing, for example, a property, I want to rent it, for example, okay? I can say a viewing entity, if I want to represent this data, I need two keys to identify this process, two keys. My number as a client and the property number. Is that correct? Okay, so this means that we have something we call composite key. is another type of candidate key that consists of two or more. Like, for example, two primary keys that identify this distinct object. Two primary, like what I said, viewing. This is a property, okay? I am viewing this property. I am viewing a house. Okay, what I need to know that will identify this process, viewing. Two main things. My ID, the client, okay? Client ID and property ID, right? These two pieces of information are very important to identify this process. This means that these two are both. It includes more than one attribute that identifies this distinct object. Okay? For example, here I'm going to give example here about the newspaper. So they are together. The values together are uniquely identifies this, for example, entity occurrence. So property number and newspaper name. Okay, for example, displaying or advertising news properties in newspapers. When we are advertising some properties in a newspaper, what is the most, the most attribute that is used to uniquely identify this process, advertising? Two main piece of information, which are property number and the newspaper name. Okay, for this process, because many properties are advertised in many newspapers. That's why we need to know which newspaper name and which property ID. So these two will be composite key. Okay. Well, how we decide if it is the composite key or it's just a primary key? How we decide? How we can decide that? By understanding the relationship, understanding the process. Okay, by understanding the relationship between these entities. All right. So I have displayed this before. How we can represent the attributes here. So, for example, an attribute can be a primary key, candidate key, which is selected to uniquely identify this distinct object. So primary key is, this is an example. This is one, a staff number. Okay, so this is the primary key. It's okay. شخطت عليه يعني مو مهم مثلا. Okay. So this is an example about primary key. Yes. It's okay. I think I have. You will not use it? Yeah. You know what? Okay. Okay, no problem. Okay. All right, just a minute, guys. Okay.
Then you assume that it was. Yeah. They are time.
All right. Thank you. Okay. Seems more smoothly on the board. All right. So staff number is an example for primary key. For example, the derived attribute. These all are like what? Single value. Okay. Or let's say, for example, the position is simple. Okay. And most of these attributes are single value. How about composite attribute, which includes what? Yeah, these are components, multi-components. Okay, the telephone number is multi-value because it can accept more than one type of telephone numbers. We can add these. And the total staff is the derived. So it means it's calculated based on another piece of information. Okay, so this was the attributes. There are two concepts here we need to understand. There is strong entity and there is weak entity. What does it mean? Strong, weak. Strong, it's not dependent on another attribute. Okay? It's not dependent on other entity type. While weak, it will be dependent on another attribute in another entity type. Like, for example, I will give you here an example. So if it is strong, then it will include a primary key that uniquely identifies this entity type. Okay, this entity occurrence. So what we said here, strong entity type is it's not existent dependent on some other entity type. Not. Okay, so not dependent. Like, for example, we can call it as parent, owner, dominate. These are alternative terms for the strong one. Like, for example, staff, branch, and staff. Okay, each of these, it includes what? Includes a primary key. It's not depending on other entity type. The existence of this entity will not be depending on another entity type occurrence. Okay, so it's like parent, main, strong, or dominate. We call it also owner. Okay, how about so it will include a primary key normally. How about weak? Weak. Let's take an example about weak entity type. Weak. Weak means its existence dependent on other entity type. It cannot be existed without the existing of another entity type. Okay, so this is weak, and there will be it cannot be uniquely identified. Okay, it cannot be uniquely identified. We call it child for that parent, child, or dependent. It depends on that owner or subordinate. Okay, so this weak cannot be cannot be identified itself without depending on other entity type. Let's take an example here. There is an example, like, for example, this, as you can see in this example, strong entity will include what? Can you see? Yeah, exactly. It will include a primary key. Okay, and its own attributes. Strong, like a parent. So when a client states a preference, is the preference will be existing without client stating this preference? Preference will not be existed. It will be based on your preference. For example, let's talk about the timetable, your timetable. Your timetable is really existed in the system, or it depends on your selection, your preference for the courses. It depends on your preference, right? You are creating your timetable by selecting whatever suits your time, right? This is something similar. It depends on you, on your preference, okay, on student's preference, for example. Same with the client. When the client states preference, yes, exactly. Yes, exactly, Qasim. When we delete it, then we cannot see the preference. It will be not there because it depends on the client. Okay, I am selecting. I am the client. I am selecting. For example, I am stating something, and then without me, there will be no preference. This is exactly the meaning of. See here, the meaning of strong. See, it's like parents, and this the preference. It's like the child for that client. All right, got the point? Got it? Okay, perfect. So there is nothing here uniquely identify each preference. Nothing, just preference type and max rent. That's all. There is no primary key here. While in the client, you can see there is a primary key. Okay? Okay. There are also other type of attributes, like we call it attributes on relationship. Like this one, for example. You can see here, the newspaper advertises property for rent, and there is an attribute without stating any entity type name. This is not an entity type, it's just attributes. It's just attributes. It's not a, this can be done. This can be created. Why? Because sometimes we need to add more attributes based on this relationship, based on the advertisement relationship or advertisement relationship. We can, for example, only have two attributes, which are cost and date advert. Okay, just attributes, not an entity type. There is no need to have whole entity type occurrence here. Just attributes on relationships. Okay, as required. Yeah, it doesn't mean that we need to use it, but it can be used. If you decide, for example, one of your relationship, you think about it. Okay, if it requires to have more attributes to be stored in the database without having an entity type, you can do this. You can still do this because it can be also, it works this way. So there is a need in this example. You can see there is a need to, sorry, there is a need to have the on the advertiser's relationship, we can just record two more attributes. So we call it attributes on relationships. Okay? Attributes on relationship, it can be assigned to a relationship, okay, to indicate that the relationship conceal an identified entity type. Also, for example, you are not sure about the entity type, you didn't identify it yet, so you can also have the attributes on relationship till you identify that entity type, and then you can have it. Okay, this also can be done. Okay. Now let's talk about the structural constraints. As I said, there are some constraints that restrict some of the relationship occurrences. Okay, and it should reflect the restriction. Okay, as we said, in the real world. Like, for example, the real world, a property must have an owner. This is a restriction, right? We can have a property without an owner? It cannot be. All right, so this is an example. Also, branch. Can we have a branch entity without any staff member? We cannot. So there are some restrictions. So the main type of restrictions or constraints will be called multiplicity. Okay, so this is the main type of restrictions. Multiplicity. As we said, where I put it here. You remember when we draw the relationship between two, I said one to many, or one to one, the number. this one. This is the multiplicity, okay? Okay. Now, let's talk about multiplicity and what does it mean? What we mean by having multiplicity. It's number of possible occurrences of an entity type. Okay, it can be single occurrence of the relationship, in a relationship. So, let me give some examples. So the representation for the business role might be understood as multiplicity. Okay. So you need to make sure that all relationship has this facility. Okay, all relationship must include the constraints. We need to have it for all relationships because we need to restrict it. So let's talk about the types. We have number one, one-to-one. Okay. Then one-to-many. And three, many-to-many. As I said, there are one-to-one. So, for example, a member of a staff manages one branch. One manage one. This is the meaning of one-to-one. While one-to-many, for example, a member of staff oversees many properties for it. Okay? And this is number one, one-to-one. Manager or a member of staff manage one branch, one by one, one-to-many, like, for example, a member of staff oversees many properties. Or number three, many-to-many, newspaper advertise many properties, property for rent. Okay, right? So many newspaper advertises many property for rent. Many-to-many. Okay. It's important to know that not all integrity constraints can be represented using the ER diagram model, but it depends on the requirements. Okay. At the end of the day, it depends on the requirements of the organization, user requirements. Okay, so let's talk about the one-to-one relationship and a semantic net. You remember the semantic net? How we can represent the relationship? We can represent it in both types, the AR and the semantic. The semantic means it's like an object-oriented representation for the relationship. We can draw an oval shape for every element, like an oval shape for the staff, oval shape for the relationship, and oval shape for the branch. All right. So as you can see here, the one-to-one relationship can be represented this way. And how many occurrences in the staff entity type? How many occurrences? We can see three. SG5, SG37, SL21. These are three member of staff. Okay. So if we want to represent it one-to-one, which means one member of staff will manage one branch. Okay. We can see here there is one relationship occurrence manages with one branch, which is B003. And the other one is L21 is the manager, the other one of B005. Can we have this? Can we say like, sorry. Can we draw like this? Let me just change the color. This one, and we link it to the same branch. Can we have this one? No, this is wrong. Okay, this is wrong. We cannot do that. We cannot have two managers for one branch, right? So this is a restriction. We are restricting the number of staff that are managing branches. Okay. All right. So here in the ER model, on the other hand, you can see here. You can see staff number. Okay, so staff entity manages branch entity. Now, what we can state here as a multiplicity, see here, the number that are represented on both sides of the relationship can be known as multiplicity. See, this one from this side, the other one is from the other side. What does it mean? 1 to 1. It means that each branch is managed by, see, each branch 1 is managed by one member of staff. Okay, who can tell why we put 0, 1 on the other side? Why we put 0, 1? Okay. Okay. Yes, this is 1 to 1.
A branch needs staff or staff will leave the branch.
Yes, that's the point. But maybe you didn't phrase it properly. The point is not all member of a staff will be managing branches, right? This makes sense. Not all member of a staff will be managers. There are different roles. So it can be 0 member of staff will manage 0 to 1. Yeah, for example, a member of staff can manage 0, not 0 member of staff, sorry. So each member of staff can manage 0 or 1. So not all of them will be managing a branch, right? If you think about it. So if you want to read, just put this in your mind. I know the time is almost done. The time is almost up. Just if you want to read it from this side, you can read it from the name of the other entity type. See here, 1 to 1 means each branch. So you start with the other entity type. Okay. When we talk about the 1 to 1 here, we can read it from this way. Each branch, okay, is managed by a member of staff. Reading the multiplicity will be this way, okay. So this is 1. How about this one? How we can read it? 0 to 1. 0 to 1 can be how? Each member of staff. Yeah, so we start with each member of staff managed by 0 or 1 branch, from 0 or 1 branch. Got the point? يعني لما بنقرا المالتيبلسيتي نبتدي بالاذر entity type. Got it? من صوب الستاف نبتدي نقول each branch is managed by 1. Okay? ومن صوب البرانش each member of staff نبتدي بالثاني. Got the point? So we start with the other entity type if we want to read the multiplicity. It's not. It's still the same. 0 to 1 branch. هذه 0 to 1 branch. Okay? You will get this by having the multiplicity. We will talk in more details, inshallah, next time. You will get the point. Okay? So that was all for today. Let me see the attendance here. Sorry, yani, we are going very slow, but yeah, we are sticking to the syllabus anyway. This week we need to finish chapter 12, which is yani, achievable. Inshallah, we are going to finish it by this week. Let me just print screen here. Okay. Again, sorry, huh?